Hi everyone, let's start solving today's Leetcode daily challenge question. Find the longest valid obstacle course at each position. So, without wasting your time, this question is simply the length. We need to find out the length of longest increasing subsequence for every index I of the array obstacles. This is it. This is the question description. If you read the question, that is fine. If you understand the question, that is also fine. But that is the whole point of this particular question. That's it. Okay, so let's jump to the solution. How we can solve this particular question? So to solve the question, the first way is the DP manner. Okay, so we can solve this particular question using DP. So where we can find out the recurrence relationship. So what will be the recurrence relationship in this question? So how we can use recursion? So for every sub problem, we can find out what can be the second most element, the second last element I can include in my array, where I will be including the ith element. So the particular array or the particular subsequence will become the longest increasing subsequence, and I can find out the length using the sub problem solution. Okay, so that was the recurrence relationship. So let's write it down. So what was that? For every state of I will iterate the whole array, which is like where I am storing, where I stored, like in DP array where I stored from 0 to I minus 1. Let's say it is j. Okay, so for every j from 0 to I minus 1, I need to iterate, and I will find out which particular index I can include in my current subsequence. So the if condition for that, if a of j is less than equal to a of I, and I can include this particular answer into my current subsequence length by adding +1 in it. So this is the DP solution, but the time complexity of this particular solution is n square. So now we need to, as per the constant, we need to optimize this particular solution, because the constant is nothing but 10 raised to power 5. We cannot implement 10 raised to order of n square approach. Okay, so let me try to explain the second approach using a very simple example. Okay, so let's take this example 1, 10, 2 and 3. So I will generate an LIS. So what will be the initial value of my LIS? For our reference, let's find out the maximum value of the array, and with I will initialize my LIS array with that particular value. So LIS I am initializing with 11. Okay, now I need to find out. Okay, now I need to find out my LIS. I maintain my LIS. Okay, so if I came at the 0th index, where I can put this particular element in the LIS array, so the whole array will be in the sorted manner or in the LIS manner. So how I can find it? How I can find it out? Using the binary search. So it will return me which index? 0th index. Okay, so if I place 1 here, my LIS will be this is an LIS now as well, so it will return me 0th. Okay, now if now I came to 10th element, the first index. Now where I can place 10 in my LIS array, so the whole LIS array is valid. So can I place it at 1? No, I can place it at the first index. Okay, so I placed it at 10 at the first index, and it, so what I'm storing here is, it is a return value from the binary search. So at the 0th index I can place my 1, and the first index, the 10th value, I can place in the first index in my LIS array. So I returned 1. Now I came to second. Okay, second index, the value is 2, where I can place 2 in my LIS array. So the whole LIS array is valid. Can I place it at 1? No. Can I place it at 10? Uh, yeah, I need to place it 2 here, so the LIS will be valid only. So I placed it 2, and the answer of this is 1 only. This I find out using the binary search. And now I came to this index. The index is 3 and the value is also 3. So where I can place 3 in my LIS array, so the LIS array is valid. So I cannot place at 0th index, first index. I can place it at second index. So I replaced 11 with 3 at the second index, and the answer of this is 2. Okay, now if I see the relation between the answer of this particular example and with this binary search return values, I can see the relation. Let me write down the output of this particular example. So for this index, the length of LIS will be 1. For this it will be 2. Let me write in a different color so it will be easy for us. So the this is 1, and for 1 and 10 the length of LIS is 2, and 1, 10, 2, the for this particular index the length is also 2. Okay, and for 3, what is the length of the LIS? It will be 3, because I can include 1, 2 and 3. Okay, so that is longest increasing subsequence. Okay, now as I was asking what is the relationship between the output, so this is the output, and between these array. So if I write this down, the output 1, 2, 2 and 3, can you guys able to see any relationship between these two arrays? Are you able to find out any relationship? Yes, we are able to find a relationship. This is nothing but +1 in the binary search result output array, and if I add +1 in those values, I am able to find out the resultant array. Okay, so this is nothing. 0 plus 1 is 1, 1 plus 1 is 2, 1 plus 1 is 2, 2 plus 1 is 3. So this is same as my output array. Okay, so this is the way we can solve this problem using binary search. So one more point, or I can say one more note, using this particular solution we can only able to find the length of LIS. Okay, the length of LIS we can find out easily using the binary search, but if we want to compute LIS using this approach, so in that case it will not give us the right answer. So do not use. If the question is about finding out actual LIS, okay, so in this case we will not use this particular approach. So this particular approach is only for when we need to find out the length of the LIS. Let me give you a code walkthrough of this. So as per the constraints, the maximum value obstacle of I can be 10 raised to power 7. So I initialized an constant named as max, which is 10 raised to power 8 plus 1, and I initialize an LIS array and the length of LIS, which I will return at the end. Okay, So the whole LIS array I initialize with the max value. Okay, so now for every index of the obstacle array, I find out the value and store it in the value constant val variable, and I am finding out index for value in LIS array. So in LIS array, where I can put this particular value, so the LIS is valid. Okay, so this particular find index method is nothing but a binary search. Will come to that as well. And after finding out this particular thing, the index, I will replace my value in the LIS. So LIS of index is equal to value. Now length of LIS of the particular index is nothing but index which I returned, which I get it from find index method plus 1, which we discussed about, and at the end I will return the length of LIS array where which I am computing here. Okay, so let's jump to the find index method. This is nothing but a binary search. So I initialize my pointers left and right. So this is my search space from left to right, and I computed the mid, and if mid is less than equal to value, so I am reducing my search space by incrementing the left pointer, or else I am reducing the search space by pointing my right pointers to mid, and at the end I am returning my L. So this whole thing is order of n, and for every index, for every ith element I am finding the index in the LIS array, so which is nothing but for every ith element is taking log of n time, so the overall time complexity will be order of n of log of n. So that's it, that is it about this question. And if you are able to get the intuition after this video, so please like this video and subscribe to my channel, and I hope you understand this particular approach, how we find out the relation between the output and the particular array output array we find out after using the binary search. So that's it about this video. Thank you so much, guys.